Hello everyone, welcome back to CSC Core Concepts in my series of machine learning algorithms. In my last video, I have discussed about an introduction about machine learning. What do we mean by machine learning and how it is different from your deep learning or AI in a broader sense. And what about data science? And of course, we have discussed about the applications or where they are being used and how they are being used. Now let us get started with machine learning algorithms. But before we can jump into the algorithms, I want you to revise this classification again, that algorithms are classified, you can see broadly categorizing. They are classified as supervised learning, unsupervised learning, and reinforcement learning. So first we are going to focus on supervised learning algorithms. And in precisely supervised learning algorithms, we have further two classifications. That is for the two categories, that is classification and regression. Now, when are you going to choose classification or when can we apply regression? That depends on the type of the data on which we are applying the algorithm. Now, in case if your data is a discrete data, so what do we mean by discrete or continuous data? So let me revise again. I have already discussed in my previous video. So discrete data means when you have the data is not continuous, meaning if I am saying that I have four colors of car, red, blue, white and black. Okay. Now for each color I am assigning some code 0, 1, 2 and 3. So the data is discrete. I cannot have a 0.5 color or 1.5 color. So this makes this is your discrete data, and if your data is discrete, then we are going to use classification. In classification, we can have binary classification, means there are only two classes, either 1 or 0, yes or no, true or false. So either it is yes or no. So only two classes. We can have multiple classes, let's say, or multi-label classes, where we can classify the objects into multiple types. Let's say I have color red, green, blue, or if I am saying vehicles in the broader sense, then I am assigning labels to each of the vehicles, that is car, scooter, cycles, auto rickshaws. They are multi-label classes. And if in case your data is continuous data means, let's take the temperature. If my data is temperature, I am recording the temperature per hour. So my temperature can be 38.4 degree, 38.5 degree, 34.6 degrees, right? So it is not like that. Temperature can either be 38 or 39. It cannot be in between them. No. So decimal point values are allowed here. So even in case of your age or your height, we say 5 feet 6 inches, like that, right? Or age, we can say that 1 year 2 months old. So this data is continuous data. So in case your data is a continuous data, we go for regression. So broadly now I am going to discuss in this video about the classification techniques, about what is classification, and a very important part of machine learning algorithm is data. So before using the data, we should ideally understand what are the different types of data available. I just gave you two examples like continuous or discrete. Then in discrete also you can have various types of data. So in this video, I am going to give you an overview of classification. What do we mean by classification or precisely supervised learning? And then we are going to discuss about the types of data. So in general sense, if we consider, if I want to know the meaning of classification, we say what? Separating or ordering of objects into classes, right? Now here, the classes are created without looking at the data, that is non-empirically, and hence this is called as a priori classification. Priori means before the data was seen, the classes has been decided. Okay, say for example, I have told you to bring fruits. Okay, and I told you to bring three categories of fruits, right? Now fruits have not yet been arrived. So fruits, the basket of fruit is what? My data, right? It has not yet arrived. But priorly, I have told, prior to arrival of the fruits, I have told you that I have to have three classes of fruits. Let's say banana, guava, and orange. Okay, so let's say. Now, after the basket has arrived, so one thing is clear to me that whatever data is going to come to me, there can be only three options available, or they are under only three categories, right? Either the data can be a banana, or the data can be an guava, or the data can be an orange. That's it. Nothing else than that. So before the data is being seen, okay, so say for example, I have lots of data. I am collecting the medical reports of patients, and there are only two output possible. Either the patient has heart disease or he does not have heart disease, right? So before my I collect the data, I know what my output is going to be, right? So my output will be either, if I'm saying yes, the person has heart disease, so it stands for 1, and if he does not have any heart disease, it stands for 0, right? So there can be only two categories, and I know that this is the only possible output. So when you know your classes prior to getting the data, or you know what you are going to do, that is called as a priori classification, or they are also called as supervised learning. Supervised means you are learning in a supervision about the classes, that the classes are known and they has to be supervised. So practically what we do is that when we get lots of data, we split the data into two parts, like training data and testing data, right? Training data, for that I know already the classes, right? So I am teaching my algorithm that if you get a fruit which is yellow in color and somewhat cylindrical in shape, it is a banana. If you get a fruit which is green in color and round in shape, it is a guava. And if you get a fruit which is let's say red in color and sorry, orange in color, it is an orange. Okay, so this way repeatedly I have been telling. So what are my parameters here? Two parameters I am telling here: the shape of the fruit and the color of the fruit, right? So based on these two attributes, I have taught my algorithm that you decide based on these attributes. So I have trained my data, right? So this process is called as learning. Okay, learning the classifier model. So the model or the algorithm which you prepare. Now these algorithms are what? Customized. Okay. For me, today if I am doing the classification of banana, apple and orange, algorithm will have different attributes. But if I am doing the classification of pineapple and watermelon, obviously the attributes or values are going to change. Attributes will remain same, the shape and the color, but the values are going to be different, right? So this model is called as a classifier model, the model which will help me to classify my objects. And when we are training that object model, that process is called as learning process. And the rest of the data which I have kept for testing, I am going to give as a test case. Let me see how much my model has learned. So randomly I can give any one fruit and ask my model, so what do you think this fruit is? Now if it has learned properly, that is prediction. It will predict that yes, this is a banana. If the prediction is correct, then we say the model is accurate. And if the prediction is wrong, then we say it has misclassified. Okay, so it is actually a banana, but it has classified it as an orange. Means the learning phase has not been proper, right? So in this case, it results into a misclassification error. This is same you can understand as a teacher is teaching in the class. So when I am teaching something in my class, understood? So I am teaching, that is called as your training phase. Now while teaching, what we do sometimes is randomly we ask some questions to understand whether the students are following or not. That is called as validation. So here the training data can again be separated into some learning data and some validation data. So validation data, when I ask some random questions in the class, that means what? That I want to understand whether the students are learning properly or not. So that is a validation data. And when we take the exam, that is what? Your testing, right? So that time I am giving you some random questions, and based on your answer, I will decide whether I will be able to find out that whether you have learned properly or not. Now, if I find out that out of 10 students, only 9 students have failed and only one has passed, that means what? The learning has not been proper. So in that case, what I need to do? I need to retune you, right? That means I need to again train you, again train the model. So if my model is giving more errors, okay, the predicted class wrong is given wrong. So I need to retune again my model, right? So again, I will have to train the model properly, right? How to train and all that we will see in the algorithms. So properly I am going to train my model. Again I will test that how much did you learn. Okay, now I find that 50% of the students passed and 50% failed, right? So still I am not satisfied with the answer. Again I will retune. So I will go on doing this till I get a satisfactory output. Understood? So the same thing applies over here, that you have data, you split the data into two parts, training data and testing data, and then based on that, classes are previously known in training data. You teach them, you know the answers of the sums. So you give them the answers, they learn. Then you give them test. In the test, you give some random questions, and let's see whether they are able to follow or not, right? So now if you have two classes, you can call them a binary classification. And if you have multiple classes, right, I am giving you three fruits. So it is more than two, right? So it is called as multi-class classification. So where are these things used in a practical life? Let's say a bank loan officer is analyzing the loan applicant details to find out whether he is a safe customer or a risky customer. Okay, safe means I am labeling safe as, let's say, 1. I am assigning if I find out 1, and if I find out that no, the customer is quite risky, I will give him a label 0, right? So now safe means what parameters I will give, that if his loan amount is at par with the salary, like whatever, suppose he is taking 10 lakhs loan but his salary is 10,000 rupees, obviously he will take, this is a quite risky customer. Understood? So I have to figure it out based on the income, based on the age group, based on the gender, based on many parameters, we decide whether the customer is a safe or not. Okay, then a marketing manager is selling some electronic products in the store, and he will find out based on the customer profile that whether he is going to buy a new computer or not. So what are the attributes? If the customer wants that computer, why will which customer will require a computer? Say if he is a student, or if he is a working professional, he is into such a work where he requires to have he requires to have a laptop or a computer, he needs it. Okay, so his income is there that he can afford to buy a computer. So I am labeling two classes, yes and no. Then let's say a medical researcher. He is analyzing some cancer data, and there are suppose three types of treatments which has to be given to the patient. So based on his reports, he will decide that whether to go for treatment A, treatment B, or treatment C. Then based on that, he can label them as 1, 2, or 3. So in this previous three, you had only labels 1, 2, 1, 0, 1, 2, 3. So these all labels are what? Discrete, right? You could not have treatment between A and B. Okay, that is not possible. So this data is what? Discrete data. Now suppose if you want to predict how much a customer will spend at an electronic store, you don't know. Okay, a customer is coming to a store. He might be buying a washing machine, a fridge, a mobile phone, something. Okay, so it is not fixed that he has to buy only 40,000 rupees, 20,000 rupees. No, his bill amount could be 43,250 rupees, 50 paisa also. So that is a numeric prediction what you are doing. Understood? So either you have classes or you have a numeric, like the insurance premium. How much your premium is going to be, that depends on various parameters, right? That the insurance agent will calculate. So that is again a numeric prediction. So the first three are going to be your classifier, and this is your predictor model. So you either we can have a classifier model which will help you to classify the objects, or you can have a model which is helping you to predict that what will be the insurance amount, how much will be the what is the probable stock value. Okay, they are the predictors. So let us understand the types of attributes. So attributes are what? Basically, first let us understand what is an attribute. The field which represents a characteristics or a feature of a data object, right? It can be also, attribute is also called as dimension. See, if you are using a data warehouse is a repository of huge amount of structured data. Okay, where you are storing the data in a proper format. In that case, in data warehouse, we use the term dimensions. If I am using machine learning algorithm, we don't call attributes, so we call them features. So now onwards, we are going to refer them as features, right? And if you are as a statistician, generally they use the term variables, right? So the thing is same: attribute, dimension, feature, variables, but different approach is use the different values. Now let's say, for example, if you have a sales database, so what are your attributes or features? The customers, the store items, the sales, the amount of sales. If it is a medical database, your attributes are what? Patients, medicines, doctors, laboratory tests, etc. If it is a university database, your data can be your students, professors, and courses. So let's take an attribute, say hair color. I am going to a beauty parlor and I want to color my hair. Now they are giving me various options that which color you want to go for: black, brown, white, or red. Okay, so I am assigning values to each of them. Now whether I am giving 0 as black color, 1 brown, 3 2 white, and 3 red, etc. Now if I am selecting 0, that does not mean I am degrading myself, or if I am selecting 1, does not mean I am upgrading. 0, 1, 2, 3 are just for information. They are just for labeling. They do not have any values. Let's say marital status. You can have marital status as single, married, divorced, right? Or if you have occupation, if you are filling up a form and you have to write the occupation, you give teacher, doctor, farmer, professor, whatever. So these type of attributes which are nouns, they are called as your nominal attributes. Understood? So they are represented generally using codes such as 0, 1, 2, and they do not have any order, like single is less than married or married is higher than divorced. This is not there. It is just for labeling. They are not quantitative information. They do not signify any quantity, that black will be more, brown will be less, nothing. Just simply for labeling. So these type of attributes are called as nominal attributes. So generally their central tendency or interest can be predicted. So at the end of the day, in my beauty parlor database, I can just figure out that how many customers are going for black color, or how many customers are going for red color, or in my shop, how many people are coming from which profession. Simply just I want to analyze. That's it. Then second type of attribute having, now nominal attribute can have two categories. It can be either binary, like smoker. Either it can have only two values, yes or no. Either a person is a smoker or not. Or blood report for a coronavirus or any virus. Either he is he is having that infection, or he does not have that infection. So it can have only two values. They are called as binary attributes. Now, both have the same importance, but see, symmetric and asymmetric are there. So, if he is having a blood report positive for virus, the consequences are different. Okay, then he will have to go for a medical treatment. But if he does not have that virus, then the consequences are less significant. But suppose if you have attributes, let's say male or female, gender. Okay, both have same importance. There it does not make that if it is a male or if it is a female more importance, nothing. So these attributes are called as symmetric attributes. And if the value have some weightage, positive or negative, they are called as asymmetric attributes. Okay, then let's say we have certain attributes in a store. Say I'm going to McDonald's and I am ordering some drinks or French fries, right? So in that case, I can order for a small, medium, or large. Now it does have a Significance, quantitative attribute, because small the amount will be less, okay, or the portion will be less. Medium and large, so they differ by the portions. So these attributes where they are quantitative, they are signifying the quantity or the amount, they are called as ordinal attributes. Then comes our numeric attributes. Now, numeric attributes can be your interval scaled. Interval scaled means they are measured on a scale of equal units. Let's say every year we have like 1 year scale is same. It is not like that, okay, 1 year it will be 365 days and the next year there will be only 22 days. No, they are equal units. Understood? So in this we say in an interval, let's say 2010 and 2018 are 8 years apart. Today it is 2 degrees warmer than yesterday. Okay, so they are interval scaled. And ratio scaled have a zero inherent point. Means you can have a zero. We can say, let's say height is twice. Okay, weight is double, right? So that is how. But in temperature, beyond zero, you can go no 0, -1, -2 like that. Okay, but in ratio scale, 0 says you start 0, 1 kg, 2 kg, 3 kg like that. Okay, they are ratio scale. Then comes your discrete numerical attributes. I again told you that they can be discrete, that is finite or incountably or countably infinite. Hair color, customer ID. Customer ID is what? Countably infinite. There can be lakhs and lakhs of customers coming to Walmart or any marts. Right. So infinite customers are coming, but there is a countable. They are countable, right? So that is discrete, and continuous means they can be represented using a floating point. Let's say the height, the weight of the person. Fine. So that's all about today's video about your attributes and overview about your classification category. So from my next video, I'm going to start with actually the machine learning algorithms. So before jumping into a supervised or non-supervised or any other algorithm, I want to discuss a very, very important algorithm which is called as an a priori algorithm. Basically, this algorithm is used by the retail sectors in order to predict or find out the placement of a product. Okay, so don't forget to like, share and subscribe to CSE Core Concepts for more such informative videos. Thank you.